We were just talking about monolithic design, and we said that it leads to problems when we come across big programs. So we are going to look at these two solutions and what we can do about that. So the first problem, which is it's hard to get your head around the whole program at once. So for this reason, we use modular programming or modularizing your code. So, what does this mean? Well, we want to take a big piece of code and we want to break it down into smaller pieces and then solve those smaller pieces. And in the end, we want everything to be connected to each other to function as one big program. So in Java, we have a different name for modules. We call them methods, right? So a method is sort of like a grouping, and it has a name. And we'll look at these things in more details over the coming lessons as well. But first, let's take a look at this application. And on the left hand side, we have a monolithic design of the same application. And on the right hand side, we have a modular design of the same application. So just to remind you, monolithic means having one big thing with everything on it. So that's what we have here. Now, I haven't really shown actual code here because that's not the point. But imagine that you have code and we'll call them operations. So we have operation 1, 2, 3, 4, 5, and then it does 4, 5 again, and then finishes off by doing 1, 2, 3. So you can see that there's some repetition that's taking place here. Can you identify what's being repeated? So 1, 2, 3 is repeated down here as well in the end. And there's 4 and 5 repeated over here. So the actual number of repetitions is not the most important thing at this stage, but you can see that, okay, so certain parts or certain sequences are repeated. So that's what we can do, and that's what we use or look at when we are breaking the problem down into methods. So as I said, a method is just giving a sequence of operations a name and putting it into a group to simplify the concept. So you have already seen the main method. That's where we wrote everything. So you're just creating new methods and you get to choose the names for your methods and quite a few other things as well. And we are not going to go into the full details of that just yet. That'll be covered in a different lesson. And so what have we done here? We have taken the first three operations and we have created method 1 and we have put that inside. We have put operations 1, 2, 3 inside method 1, and method 2 has operations 4 and 5. So the method itself has no mention of how many times things are repeated or anything like that. It's just like a grouping, and we have given it a name. So let's go into the main method. When you're looking at a program with multiple methods, always start from the main method because that's still the entry point into your program, just like in a monolithic program, everything starts running from the top inside the main method. Even if you have multiple methods, it's still going to start from main. So when you press the run button under Eclipse, it'll start from the first line inside the main method. Now the first line in the main method looks a bit different. You may not have seen something like this before. So it says name of class and object name. And so you can see the name of class is the name of the class that we have written up here. I've kept it like that so that you understand it can be whatever the name that goes up there. So we have created what's called an object reference or an object handle over here in the first line. And on the second line, we are actually creating an object. Now, this is not something I will discuss right now because that is for the lesson that covers object-oriented programming. But in order to stick to that end goal or that theme, I have done it this way. So right now you don't need to worry about what these two lines are doing. So the actual concept of modularity is demonstrated, or the general concept is demonstrated from by the last four lines in our main method, where we say object name. Okay, so that's the name of the object, which we have to write anyway. And method one. So as soon as it reaches this line, we said that the program starts from the main method. It does one line at a time. And as soon as it gets to this line, what it'll do is it'll see, okay, you're saying method one, all right. So I will go to method one and it'll start doing method one line at a time. So it'll do operation 1, 2, 3. And after it finishes the last line inside that method, it'll go back and resume from the line after, which is this one. So it's almost like you took everything back and replaced everything, but there is a difference. So what you have to understand is when it gets to a line that has a method name mentioned, it calls that method. So calling a method is like calling a friend. You know, when you want help, you call a friend to get something done maybe. So this is doing the same thing. It calls the method and the method does its operations. So it's also important to ensure that this method can do these operations by itself. So the method itself has to be, or the lines of the code inside the method, they have to be standalone. So if you needed additional variable declarations or anything like that, there is no communication between method one and method two right now. So that's why I said that it's not the same thing as taking this code and inserting here, because then you don't need to worry about missing declarations inside the method. So each method has to take care of itself, in other words. So after it finishes the first method, or the first method call for method one, it'll do the next line, which is going to do method two. So it's going to start method two. And again, it'll do the lines of code 4 and 5, one after another. And we have to make sure that those two lines can run normally inside method 2 by themselves. And you can see after it finishes, it'll go and do method 2 again. So when it encounters method 2 being mentioned, or when our main method calls method 2 for the second time, it is rerunning everything from scratch. In other words, the variables that were declared inside method 2, method 2 will not have any recollection of the previous values that you had. So everything gets reset after the method finishes, or you can think of it as every time a method is run, it has no memory of things that happened before. So this is another reason why the method has to take care of itself. The code has to be standalone to simplify. All right, so finally, method 1 is run again. So again, the concept is as soon as it encounters that line, it jumps to this position and then it does all the lines of code inside that method and gets out. So that's the general idea behind breaking things down into methods. You can try something like this out under Eclipse. You can start off by putting hello world outputs, or maybe 7 or 8, or we have actually only 5 different outputs. So create 5 different messages and get it to work like in the monolithic design, which should be easy right now. And then create a new Eclipse project and break it down into several methods like this, and then get it to work this way. Change various values and see what you can have, and what's allowed and what's not allowed, and experiment And we will talk more about methods again soon. So this is the summary of what I just explained. So it's essentially the same things. Again, this part is not that important to get into right now. We will look at that later on. That's the end of this lesson.